Hello dear student, in standard 10th mathematics, here chapter number 2 polynomials and part number 8. In part number 7, we have studied relationship between zeros and coefficient of quadratic polynomial, that we how we describe a relationship between zeros and coefficient of quadratic polynomial. Now in this chapter, in this part, that we are going to study relationship between zeros and coefficient of a cubic polynomial. Now we find zeros and uh, by algebraic operations we find relationship between zeros, and then we find relationship between zeros and coefficient of cubic polynomial. Now let relationship between zeros and coefficients of a cubic polynomial. Now, let me understand this relationship between zeros and coefficient with one example. Here given example, that is, let us consider any cubic polynomial as p of x is equal to 2x cube minus 5x square minus 14x plus 8. This is a cubic polynomial that we now we find a relationship between zeros and coefficient of cubic polynomial. Now, solution, let we can check that p of x is equal to 0. When we get p of x is equal to 0, when we put zeros of given polynomial in it, and then it makes p of x is equal to 0. Now, we also know that cubic polynomial has at most 3 zeros. So now here we now check that p of x is equal to 0 for the values of x is equal to 4 minus 2 and half. Now we replace x by these values in p of x, and then we get p of x is equal to 0. Then we can say that the given values of x are zeros of given polynomial. So p of x has at most 3 zeros, as we know. Now first we check here. Now we check relationship between zeros and coefficient. Now we know that for values x, 4 minus 2 and half are zeros of polynomial. So now we find a relationship between these zeros. So first one is that relationship is that sum of zeros. First relation between zeros is sum of zeros. So now we do summation of given zeros. So now here you can find 4 plus minus 2 plus half. So we find LCM, or we do equal denominator. So we multiply 2 with 4, that we get 8. 2 with 2, that we get minus 4. And here 1 has already denominator as 2. So here you can find 8 minus 4 plus 1 by 2. Then we get 5 by 2. Now we can 5 by 2 as minus 5 minus into minus 5 by 2. So now here we know that minus 5 is a coefficient of x square, the second term of cubic polynomial. So and 2 is a coefficient of x cube. So here we have find relationship between zeros and coefficient, that is sum of the zeros is equal to minus coefficient of x square divided by coefficient of x cube, that is given as here. Now we know that coefficient of x square is minus b and coefficient of x cube is a. So we can write this relationship as here given, that is minus b by a. When we find relationship between zeros and coefficient as a sum of zeros that equal to b minus coefficient of x square divided by coefficient of x cube, and which is equal to minus b by a, where b is a coefficient of x square and a is a coefficient of x cube. So this one is first relationship between zeros of cubic polynomial and coefficient of cubic polynomial. Now let me find another relationship for this. So second relationship is product of zeros. Product of zeros. Now here we have three zeros, then we do multiplication of them. So here we get 4 into minus 2 into 1 by 2. Here 2, 2 will be cancelled. So here remaining part is minus 4, and we can write minus 4 as minus 8 by 2. Minus 8 by 2. Now here we know that 8 is a constant term and fourth term in cubic polynomial. So here minus and 8 is a constant term and 2 is a coefficient of x cube. So here you can say that the product of zeros, second relationship is product of zeros is equal to minus constant term divided by coefficient of x cube, that is minus d by a. What is minus d by a? So this one is second relationship between zeros and coefficients of cubic polynomial. Now about third relationship between zeros and coefficient of cubic polynomial. Now third relationship is sum of the product of zero. First we find two products of zeros and we do sum of them. So now third relationship is sum of the product of zeros. So here first two zeros, we multiply first two zeros, that is 4 into minus 2, then we do addition second and third, minus 2 and half, and third one is third and 1 is half multiplied by 4. So we first do production product, we take product of polynomial and then we do summation of them. So now 4 into minus 2 is equal to minus 8. Here 2 are cancelled, then minus 1, and here 2 2s are 4. So here find plus 2. So now we evaluate, then we get minus 7, and we can write minus 7 as minus 14 divided by 2. Minus 14 divided by 2. Now we know that minus 14 is a coefficient of x. Minus 14 is a coefficient of x and 2 is a coefficient of x cube. So we can write c by a. So it is a third relationship between zeros and coefficient of a cubic polynomial. So this one is sum of the product of zeros is equal to coefficient of x divided by coefficient of x cube, that is c by a. C is the coefficient of x and a is a coefficient of x cube. So in general, we want to write for any cubic polynomial, that is in general, let assume that alpha, that we already studied, this sign is called as alpha, this one is beta, and third we get sign gamma. Third sign is gamma. So here three symbols are alpha, beta and gamma are zeros of cubic polynomial, because cubic polynomial has at most three zeros. So we have to assume that alpha, beta and gamma are three zeros of cubic polynomial. So of cubic polynomial as p of x, that we know standard form of cubic polynomial, that is p of x is equal to ax cube plus bx square plus cx plus d, and a does not equal to 0. So here relationship between coefficient and zeros. So sum of zeros is equal to alpha plus beta is alpha plus beta plus gamma, that is minus b by a, that is coefficient of x square divided by coefficient of x cube, and we put minus sign. So this one is first relationship between zeros and coefficient, that is sum of zeros is equal to minus coefficient of x square divided by coefficient of x cube, that is minus b by a. Now second relationship, that is sum of product of zeros, sum of product of zeros. So first we do product, first we take product of two zeros and then we do addition. So now here sum of product of zeros we can take as alpha beta, beta gamma, and gamma alpha, and we do addition of them. So we get is equal to c by a. Here we know that c is a coefficient of x and a is a coefficient of x cube. Now third relationship, that is product of zeros, product of zeros. So we do product of, we find product of zeros, that is alpha beta and gamma, and at last we can write is equal to minus d by a. D is a constant term and a is a coefficient of x cube. So product of zeros is equal to minus d by a. So this was about the relationship between zeros and cubic polynomial. Now let me solve one example and we understand by one more example, that is example number 5. Verify that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial p of x is equal to 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between zeros and coefficient of given polynomial. So solution of this, first we check whether 3 minus 1 and minus 1 by 3 are zeros of p of x or not. So let p of x is given as p of x is equal to 3x cube minus 5x square minus 11x minus 3. Now for coefficient of cubic polynomial, we compare this give polynomial with standard form p of x is equal to ax cube plus bx square plus cx plus d. Then we get a is a 3, b is equal to minus 5, c is equal to minus 11, and d is equal to minus 3. So whenever you take or you compare with standard form, then you have to also look at sign of term. Now let me verify that 3 minus 1 and 1 minus 1 by 3 are zeros of polynomial. That how can we know that? How can we check this? By replacing the value of x in p of x. So now first value is 3, so x is equal to 3. So now we put in p of x or we replace x by 3, and if we get is equal to 0, then it will be a 0 of given polynomial. So p of 3 is equal to 3 into 3 cube minus 5 into 3 raised to square minus 11 into 3 minus 3. So here 81 minus 45 minus 33 minus 3, and at last we get that is equal to 0. So x is equal to 3 is a 0 of given polynomial. Now about x is equal to minus 1. So we put or we replace x by minus 1. So we get p of minus 1 is equal to 3 into minus 1 cube into minus 5 minus 1 square minus 11 into minus 1 minus 3. So is equal to minus 3 minus 5 plus 11 and minus 3. Or evaluating it, we get p of minus 1 is equal to 0. So we can say that x is equal to minus 1 is also 0 of given polynomial, cubic polynomial. Now about third 0, that is x is equal to minus 1 by 3. Now we again replace x by minus 1 by 3. Then we get p of minus 1 by 3 is equal to 3 into minus 1 by 3 cube minus 5 into 1 minus 1 by 3 square minus 11 into minus 1 by 3 minus 3. Now evaluating it, at last we get is equal to 0. So here is equal to 3 into minus, we find cube of 1 over 3, and we know that for odd exponent minus sign always remain as, and for even exponent as 2 here you can see that the sign will be positive. So here we find 3 into minus 1 over 27 minus 5, and here minus sign will be positive. So here we find 5 into, now we find square of both. One is square of 1 is 1 and square of 3 is 9, and minus minus plus 11 by 3 and minus 3. Now here 3 nines are 17 27, or we put here that is 1 minus 1 over 9 minus 5 by 9 11 in. Here we want to make equal denominator, so we multiply here, or we divide by 3, multiply and divide by 3, or here also we multiply and divide by 9. So here we know that if we multiply 3 with 3, then we get 9 as a denominator. So here I have multiplied numerator and denominator with 3, and here we want to put here denominator as 9, so here we have to multiply 9 with numerator. So here you can find minus 1 over 9 minus 5 by 9, 33 by 9 and 27 by 9. So here at last we know that if denominator of all term are equal, so we can put only one denominator of terms. So here minus 1 minus 5 plus 33 minus 27 divided by 9, and at last we evaluate, then we get is equal to 0. So we can say that x is equal to minus 1 by 3 is also a 0 of p of x. So here we verified, that is x is equal to 3, x is equal to minus 1, and x is equal to minus 1 by 3 are zeros of given polynomial. Now let we verify relationship between zeros and coefficient. So x is equal to 3 minus 1 and 1 minus 1 over 3 are zeros of p of x that we have verified. Now let alpha is equal to 3, as we assume that alpha is a 0 of p of x, beta is a 0 of p of x, and gamma is a 0 of 0 of polynomial. So alpha is equal to 3, beta is equal to minus 1, and gamma is equal to minus 1 over 3. Now first relationship, that is sum of zeros, that is alpha plus beta plus gamma, and which is equal to 3 plus minus 1 plus minus 1 by 3, and we get 3 minus 1 over 3, that 3 minus 1 is equal to 2 and minus 1 over 3, or we subtract 2 by 2 1 by 3 from 2, then we get 5 by 3, and we can write 5 by 3 as minus 5 by 3, and we know that minus 5 is a coefficient of x square, so and a is a coefficient of x cube, and at last we verified first relationship. Now about second relationship. So sum of product of zeros, that is alpha beta plus beta gamma plus gamma alpha, so is equal to 3 into minus 1 is equal to 3 into minus 1 plus minus 1 into minus 1 over 3 and minus 1 over 3 into 3. So 3 into minus 1 minus 3, minus minus be cancelled, so 1 over 3 and 3 are cancelled, then we get minus 1 minus 1 minus 3 and minus 1 is equal to minus 4 and plus 1 over 3. At last we get minus 11 by 3, and we know that 11 is a minus 11 is a C and 3 is a A. Now third relationship, that is product of zeros, is given as alpha, beta and gamma. Now alpha is 3, beta is minus 1 and gamma is minus 1 over 3. 3 are cancelled, minus minus equal to plus, and we get at last 1, and we can write 1 as minus into minus 3 by 3. So minus sign as it is, minus 3 is a D and 3 is a A. So here we verified third relationship between zeros and coefficient of cubic polynomial. So here we remember three relationship in cubic polynomial, that is sum of zeros, that is alpha plus beta plus gamma, sum of product of zeros alpha beta plus beta gamma plus gamma alpha, and third one is product of zeros, that is alpha beta and gamma. So now about your homework, here given one example, check whether given values are zeros of given polynomial or not, and also check relationship between zeros and coefficient of cubic polynomial. Here you also you have to verify that, verify this, verify zeros. Okay, so it is your homework.